Dear all, wish you a very good day. Okay, in the present lecture, we are going to study about magnetic resonance imaging system, that is MRI, and particularly we will be focusing on nuclear magnetic resonance NMRI. Okay, previous to this, we had covered in the previous lectures we had covered topics related to CT scan, where X-rays were utilized for detecting bones and body tissues. Okay, now magnetic resonance imaging is different from this in the sense that basically the field is focused on detection of fluids and liquids in the body instead of focusing on bones and body fluids. Okay, so this gives us a different dimension and different it helps us to detect different compounds of our body and body fluids which were earlier not easily possible. Okay, so in the present lecture we are going to look at a brief about magnetic resonance imaging and different principles involved. Basically there are 4 to 5 principles related to magnetic resonance imaging. We will be going to cover magnetic moment in the present lecture. Okay, so let us start. Magnetic resonance imaging. Nuclear magnetic resonance NMR tomography is powerful imaging technique in the medical field because of its high resolution capability and potential for chemical specific imaging. Okay, so it is a highly recommended technique because it gives a very good resolution, and then it can easily detect chemical specific imaging that related to particular chemicals or fluids flowing in our body. It can detect those and help us get a better diagnosis. Now, NMRI uses magnetic field and radio frequency signals to obtain information about human body as cross-sectional images. Okay, in any desired direction. So with the help of magnetic fields and radio frequency signals, okay, the information can be gathered about human body, and it can be done in any cross section of the body which is desired. It can easily differentiate between healthy and diseased tissues because the focus is on the fluids, and because of the magnetic moment and because of the magnetic and radio properties, the fluids change their individual properties which can easily be detected through NMR. NMR is a map of distribution density of hydrogen nuclei and the parameters which show their motion in cellular water or lipids. Okay, so it is a map of distribution density of hydrogen nuclei. Okay, so every cell has a nuclei which contains hydrogen, and these parameters show their motion in cellular waters and lipids. So different waters and lipids, that is body fluid which is contained, is included, and related to them we can get the results. Now, the most important thing, it is a non-invasive imaging technique because it lacks of any known hazards and less attenuation in penetrating bones and air. That is, first of all, this is non-invasive technique, so it will not affect the human body parts. We are not going to make any cuts and anything we are not going to put inside the body. Second thing, the technique uses magnetic or radiography, so the bones and different fluids of our body or different tissues of our body are not affected by this. Therefore there are very less hazards or no hazards related to this technique. And finally, CT provides the detail about the bones and tissue structure. So previously CAT scan or X-ray based tomography, it was used for bones and tissue structure, whereas NMR that we are going to focus here highlights the liquid areas on the organs and can also be used to detect blood fluids. So this is basically focused on blood and other body fluids, and based on those their detection is made possible. Now we are going to focus on principles related to the NMR imaging system. The first one is related to magnetic moment. and thereafter other principles include free induction decay and excitation and emission. Okay, so presently we are going to focus on magnetic moment. Then in the succeeding lectures we will see how other parts are covered. So magnetic moment m0. Okay, the basic physics behind this is that all material nuclei are either made up of protons or neutrons or combination of both. Okay, every according to atomic theory, atom is made up of neutrons, protons and electrons. So their nuclei contains protons, neutrons or combination of both. It is true for each and every particle. Okay, even for hydrogen particle, using its different types like deuterium, neutrium, proterium, whatever the different types are, even they contains a combination of protons and neutrons. So nuclei contains an odd number of protons or neutrons or both in combination, and therefore they possesses a spin or a magnetic moment having magnitude and direction. So whatever these electrically charged particles are, protons, neutrons or their combination, they have a nuclear spin and they have a magnetic moment in a particular direction. So in a body, tissue or any other specimen, the magnetic moment of the nuclei are randomly present and net magnetization of the tissue is zero. Okay, so if we will be looking, this is the random motion in which different tissues are aligned with their magnetic moment. So their no magnetic moment is in the same direction, and because of this their net magnetic moment is m is equal to 0. Okay, so because of this, what happens when a material is placed in an electromagnetic field B0? Some of these randomly oriented nuclei experience an external magnetic torque. Okay, so as soon as magnetic field is applied, some of these particles align themselves because they experience magnetic force or magnetic torque on themselves. Okay, and they will align in the direction of the external magnetic field. So in xy plane, the magnetic moment another xy plane cancels one another, and the net magnetic moment is in the z direction. So the magnetic moment in x direction and y direction gets cancelled, and the net magnetic moment is experienced in z direction along the applied magnetic field B0. So according to the electromagnetic theory, any nucleus such as a hydrogen proton which possesses magnetic moment, it attempts to align itself with the magnetic field in which it is placed. So according to magnetic, if we have taken any proton which has been placed in a magnetic field, it will align itself with the magnetic field rather than in x or y plane. Okay, this results in the wobbling movement about the applied B0, which is resonant angular frequency. Okay, and angular frequency omega naught will be r into B0, and it will depend upon the magnetic field. Now another important phenomena which is observed is that the applied external field creates an energy absorption state, that is, some energy is absorbed. Okay, so when a nucleus with a magnetic moment is placed in a magnetic field, the energy of nucleus is split into lower and higher energy levels. So whatever the individual energy of the nucleus will be, it is divided into two parts, higher energy and a lower energy. So excitation energy of proton to excite the nucleus is given by E is equal to h into omega naught, where omega naught is angular frequency and h is the Planck's constant. Okay, this is all for the present lecture. In the next lecture we are going to look at the other three principles which are involved in NMR. Thank you.